In activity 22, we're going to be talking about trigonometric ratios. So in this first lesson of that, we're going to define sine, cosine, and tangent ratios. We're also going to calculate the trig ratios in a right triangle and then use relationships we see and know about different angles in our right triangles. So we are on page 308 in our Springboard book, so you need something to write with, and you must have a scientific calculator for today's notes and for the rest of the unit. So make sure your calculator has a sine, cosine, and tangent button before you continue. All right, we're going to start by looking at these three triangles here. So grid A, grid C, and grid E. Now they're labeled here the long leg, short leg, and the hypotenuse. So what we're going to do is use these triangles to fill in the table below. So we're going to determine the ratios in the table and write the ratios in lowest terms. Okay. So it might be helpful for you if you actually label the triangle with your lengths, so the long leg, short length, and the hypotenuse. So I would take a second and do that in your book. Okay, if you notice, all three of these are Pythagorean triples, the 6, 8, 10 triangle, 3, 4, 5, and 9, 12, 15 triangle. Okay, but I'm going to start us off by looking at, I'm going to go through angle A with you. So they want us to use angle A and find the length of the opposite leg over the length of the hypotenuse. So those are the ratios that we're going to make for this. Okay, so looking at angle A here, our opposite leg is always the one directly across from that angle. So in this problem, it would be 8 over my hypotenuse, which is 10. Now we know in math, we would never leave our answer like that, 8 over 10. So what we have to do is reduce that fraction. 8 over 10 would reduce to what, 4/5? Okay. The next box wants us to find the length of the adjacent. Remember, adjacent means the line next to that angle. So the adjacent leg over the hypotenuse. So the adjacent leg for angle A is 6 over my hypotenuse, which is 10. So reducing 6 over 10, that would be 3/5. Okay. Lastly, we're going to take the length of the opposite leg, which we said was 8 already, over the adjacent leg, which is 6. Reducing that fraction, 8 over 6 would be 4/3. So I'm going to have you guys fill out this table, finish it up for angle C and angle E. So fill in the exact same thing that I did. Okay, if you filled out everything incorrectly, you should have gotten these ratios. Okay, so something I want to point out and that we hopefully noticed is all of these for the opposite and hypotenuse were the same. Same thing with the adjacent hypotenuse ratios and our opposite adjacent ratios. They all ended up being the same fraction. And that's because all three of these are similar triangles, okay? Similar right triangles. All right, let's move on to the next page here. I'm actually going to skip down below to this box here. So the ratios of the lengths of two sides of a right triangle form a trig ratio. Okay, we usually just abbreviate it trig ratio. And the three basic ratios we have are sine, cosine, and tangent. And then you can see they're abbreviated below. Okay, so we're going to start by using a scientific or graphing calculator to evaluate each of these angles in A, B, and C. Make sure your calculator is in degree mode. So let's go to your calculator. Okay, what that means is you have to click the mode button. So right at the top, hit mode. And it's the fourth line down. Okay, make sure where it says degree is highlighted. Okay, you want it in degree mode. If your calculator is not in degree mode, you're going to get every answer wrong. So say if radian was highlighted, just arrow over to degree and hit enter. And then once your degree mode is on, you can hit second and quit and go back to your main screen. So once we're in degree mode, we can find these angle measures. So the sine of 53 degrees, you just hit sine 53, hit enter. They want us to round to the nearest tenth, so that'd be 0.8. Cosine of 53 degrees. be 0.6, and then tangent of 53. So here's what I got. So 0.8, 0.6, and 1.3. I'm going to write those in. So I had 0.8, 0.6, and 1.3. Okay. All right, so going back to that table where we found those ratios, so the ratios we wrote in the first part, we're going to express those ratios as decimal numbers rounded to the nearest tenth. So I went ahead and just copied over the ratios we got for each side, but go ahead and approximate those as decimals. So what's 4/5 as a decimal, 3/5, and 4/3? Okay, hopefully you had 4/5 is 0.8. 3/5 is 0.6, and 4/3 is 1.3 repeating, or just 1.3. So hopefully you made this connection here that these are the same as those decimals we got from the calculator. Okay. So on the next page they go over this, but I'm just going to do it here while we kind of have them side by side. But if you look at it, the opposite over the hypotenuse, okay, is going to give you the sine of a degree. Okay. The adjacent leg divided by the hypotenuse is going to give you the cosine of an angle. And lastly, the opposite leg over the adjacent leg is going to give you the tangent of whatever angle you have. Okay, so let's fill that in on the next page. I'm going to go to that. Okay, so the opposite leg over the hypotenuse is going to give you the sine. They're using acute angle x here. So that'll give you the sine of x, your angle. Okay. When we have adjacent over hypotenuse, that tells us the cosine of some angle. And again, they're using angle x here. And lastly, the opposite divided by the adjacent leg would tell us our tangent of our angle. So tangent x. Okay. Maybe you remember this or not, but our little abbreviation here is SOHCAHTOA, if you remember that. This will kind of help you remember which legs of the triangle go with which trig function. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So remember SOHCAHTOA, you could set up any trig ratio that you need. Okay, so let's use that to solve for this triangle ABC. So write the ratios in simplest form. So I'm going to go through and do it for angle A so you see what it is, and then you can go through and do angle C. Okay, so to find the sine of angle A, so we're looking at angle A here, sine would be the opposite over the hypotenuse. So opposite side would be across from that angle, so that would be 8. My hypotenuse is across from my 90 degrees, so that would be 17. Okay. The cosine is adjacent over hypotenuse. So the adjacent is the next two, okay, so that'd be 15 over hypotenuse, which is 17. Okay, tangent is opposite over hypotenuse, or sorry, opposite over adjacent. I wrote A and then said hypotenuse. So the opposite side again is 8. Adjacent side was 15. Okay. Now, these fractions don't reduce, but anytime you do have fractions that you can reduce, make sure you do that. But these ones, the numbers aren't really any divisible common factors. So do the exact same thing for angle C. Okay, so look at angle C here. Find its sine, cosine, and tangent ratio. Okay, if you did everything right, you should have had these 3 fractions. Okay, let's finish up here by just talking about some relationships that we see, okay, in these right triangles with our trig ratios. So I just recopied triangle ABC here, and they want to know how the 2 acute angles relate to each other. So in this problem, that would be like angle, how does angle A relate to angle C? Those are your 2 acute angles, the other 2 angles in the triangle. So I'm just going to make up a number here so you guys can see the relationship. So I say that angle A is 20 degrees. And again, I'm just making this up for sake of an example. So we have 20 degrees, 90 degrees. What would that make angle C? Okay, well, 90 and 20 is 110, so that would leave 70 degrees left over for angle C. So how are these related? Well, 20 and 70, what kind of angles are those if they add to 90 degrees? If you remember, they are complementary angles. Okay, so this will always be true in a right triangle. Their two other acute angles will always be complementary, meaning whatever they are, they should sum, okay, to 90 degrees. Okay, that's going to be true again, always for your two other acute angles. Okay, question C says, what's the relationship between the sine and cosine of complementary angles? So they're asking, what's the relationship between the sine of angle A and the cosine of its complementary angle, so the cosine of angle C. So let's look back at our above here. Let me get a highlighter maybe. So they want to know, how does the sine of angle A relate to the cosine of the complementary angle? So the cosine of angle C. Well, how do those relate? They're the same measurement. Okay, they equal each other. Okay, so again, they're complementary. So angle A and C, those would be complementary angles. The sine of one angle should equal the cosine of the complementary. So let's use that idea to answer letter D here. If you know the sine of 68 degrees is equal to 0.93, what other trig ratio do you know? Okay, so again, they're asking if we know the sine of 68 degrees equals 0.93, we know that that also equals what? Okay, well, it's going to equal cosine of the complementary angle. So if one angle is 68, let's do a quick little subtraction. Take that away from 90, you should get the complementary angle, which is what, 22. So those would both equal 9.93 if you plug them into your calculator. Okay, so the sine of one angle, maybe let's write it down as like a little note here. So you can write this down and have it in your notes. The sine of one angle, so we'll say angle A, is equal to the cosine, okay, of that complementary angle. Okay, so basically we're saying it would be equal to the cosine of 90 minus A. Okay. So the main takeaway of today's lesson is knowing these relationships between your angles, okay, knowing that the other two acute angles in a triangle are complementary, so you can use that to help kind of set up your trig functions. And then also knowing your SOHCAHTOA, so you can find the missing length of any side. Okay, so let's just do some check your understanding problems. I'm actually just going to have you guys try number 11. So number 11 says the sine of B is equal to 5/13. Draw a right triangle ABC with right angle at C and label the side lengths. So we have a right triangle here. They're saying the right angle is angle C. Okay, so they told you the sine of B is 15 or 5/13. So use that to help you kind of label it. But determine the lengths of the missing sides. What's the cosine of angle B and what's the tangent of angle B? Okay, so for 11, let's look at these answers here. Okay, so say this is A and we call this B. Okay, sine, remember sine is opposite over hypotenuse. So if the sine is 5/13, that makes this side 5, the hypotenuse 13. So you can use Pythagorean theorem if you need to, but this is a triple. The 5, 12, 13 triangle would be your missing side. That's why it's 12 units. Once you have your missing side, then you can find the cosine, the adjacent over hypotenuse. So 12 over 13. Tangent, opposite over adjacent, 5 over 12.